Hello everyone, hope you are doing well. Today we are going to talk about a very important concept of physical chemistry, that is vapor density and degree of dissociation. In order to discuss it, first we'll write the definition for vapor density. So it's defined as the mass of certain volume. It's defined as the mass of certain volume of gas compared to the mass of the same volume of hydrogen gas. It's defined as the mass of certain volume of gas compared to the mass of same volume of hydrogen gas at same pressure and temperature. So we'll write vapor density is equal to mass or molar mass of gas divided by the mass of hydrogen, same volume of hydrogen at the same temperature and pressure. So what will be the mass of hydrogen? That is 2. So molar mass of gas will come out to be 2 multiplied by vapor density Vd. So this is the formula for molar mass of gas, that is 2 multiplied by vapor density. Now we'll talk about degree of dissociation. This is very important concept and it will be widely used in physical chemistry. So let's discuss it. First we'll write the definition. So the degree of dissociation is defined as the fraction of original substance that dissociates into products. Like an example, here we write 1 mole of substance A dissociates into products B and C. Then we can write this equation. So 1 mole of A dissociates into n moles of B and m moles of C. So this is at t equal to 0 when the dissociation begins, and at t equal to equilibrium we can write 1 minus alpha of A was left, while n times of alpha for B was formed and m times alpha moles of C was formed. Here alpha is degree of dissociation. So alpha moles of A was dissociated when 1 mole of A was taken. Now we'll solve a problem. Here a sample of N2O4 is 50% dissociated. Find the vapor density of mixed gas. So we'll first write the simple dissociation equation. So N2O4 gas, it dissociated into 2 moles of NO2 gas. Here it is 50% dissociated, right? So we'll solve this problem. At t equal to 0 when dissociation just began, we had 1 moles of N2O4, and t equal to t equilibrium we had, let's say, 1 minus 50% is dissociated. So alpha is degree of dissociation. So alpha here will be 50%. So this is basically percentage of alpha. And if we write in terms of degree, so alpha will come out to be 0.5. So 1 minus 0.5, this much will be left, which is 0.5. And how much of NO2 will be formed? It will be 0.5 multiplied by 2, which will be equal to 1. So we have to find out the vapor density of mixed gas. So basically at equilibrium we are having two gases, N2O4 as well as NO2. So we'll write the formula molar mass average, which is sigma moles multiplied by molar mass divided by summation of moles. So total mass divided by total moles. So we'll simply apply this formula and we'll get the value of M average, and from M average we'll get the vapor density. So for N2O4 and 2 moles of NO2, we have to find out the M average, right? So we have N2O4 and NO2 gas, and how much moles of each? We have 0.5 moles for N2O4, whereas 1 mole of NO2, right? So this is at equilibrium. So how do we solve this? Let's erase this part and just put the values in this formula. So for N2O4 what will be the molar mass, and for NO2 what will be the molar mass. So on calculating we will get 46 and here 92. Now simply put these values in the formula. M average will be equal to total mass divided by total mole, sigma NI divided by sigma NI. So 0.5 multiplied by 92 plus 1 times 46 divided by 0.5 plus 1, and on solving we can get here 92 divided by 1.5, and this will be our value for M average. And vapor density, we know the formula, it is M average divided by 2. So M here is 92 divided by 1.5 divided by 2, it will come out to be 92 by 3. So this will be our answer for vapor density of mixed gas. Now we'll write that N2O4, which got dissociated into NO2. Here initially we had 1 mole of N2O4, 0 mole of NO2, and at equilibrium we have 1 minus X moles left for N2O4, whereas 2 times X moles of NO2 was formed. So here the M average formula was 92 divided by 1 plus X, where X is degree of dissociation. So percentage alpha or degree of dissociation, its value here will be moles dissociated divided by initial moles taken. Degree of dissociation basically is the moles dissociated divided by initial moles taken multiplied by 100. So this is the formula for degree of dissociation. So percentage alpha, here what is the moles dissociated, it is X divided by initial moles taken, which was 1. So it will come out to be X multiplied by 100. This is percentage alpha, alpha will be equal to X. This is the simple concept. Hope you understand. Thank you so much for watching.